Welcome, ladies and gentlemen. So today again we are talking about Avogadro's law. In the last videos we talked about Boyle's law and Charles' law, and again we cover this subtopic in gases, which is Avogadro's law. So what is Avogadro's law? So in Avogadro's law, unlike Boyle's law and Charles' law, in Avogadro's law, it is constant temperature and pressure. Now, what happens there? At constant temperature and pressure, the volume of a gas is directly proportional to what? To the number of what? Of moles. So in this video, we are going to understand, not only are you going to understand Avogadro's law, but also relate gas volume to what? To the number of moles, and also use molar volume at standard temperature and pressure. So Avogadro's law is the law that states that at constant temperature and pressure, the volume of a gas is directly proportional to the number of moles. Again, now as we said in the previous videos, you are going to find when this one increases, this one increases or reduce. But in Avogadro's law, what you are going to find is that the more the number of moles, the larger the volume. The less the moles, the smaller the volume, which means the volume and the number of moles in Avogadro's law, they are directly proportional to each other. So Avogadro's law is the law that states that volume and the number of moles, they are directly proportional to each other. Yeah. So Avogadro's law is the law that states that the volume of a gas is directly proportional to the number of moles, because as the number of moles increase, even the volume will increase. If they reduce, even the volume will reduce. Another thing that you should know also in Avogadro's law is at standard temperature and pressure, temperature is equal to 273 K. Also, pressure is equal to 180 m at 1 atmosphere. Also, 1 mole of any ideal gas occupies 22.4 liters. We'll be using this value a lot, so you just need to memorize it, which is 1 mole of any ideal gas occupies 22.4 liters. These numbers appear frequently in exams. So those are the important facts that you should know about molar volume at standard temperature and pressure. The first example is this one that I've written already. So there we go. A gas occupies 4 liters and contains 0.5 moles. What volume will 1.50 mole occupy at the same conditions? So we can see that our initial volume is 4 liters, and we have and this 4 liters contains 0.5 moles. What about a volume containing 1.5 moles? What volume will it occupy? Yeah. So what about this one that has 1.5 moles? What volume will it occupy at the same conditions? So we write the formula that we said earlier, which is V1 over N1 is equal to V2 over N2, which is volume is directly proportional to what? To the number of moles. So there we are going to have the formula of volume 2. So we just replace, because we have our volume 1, which is 4 liters, N2, which is 1.5 moles. What about N1, which is 0.5 moles? So we just place in the formula to get our volume 2. The answer is going to be 12. Now what we can see is we started with 4 liters, it has increased to 12 liters. What is the reason of this? Because even in the number of moles, we started with 0.5 moles to 1.5 moles. That is why it has increased, because volume increases with the moles. Let's go ahead and do the second example. So the second example is, what volume does 2.0 moles of gas occupy at STP? As we can see, like earlier in the video I said, 1 mole, like any 1 liter occupies 1 mole of any gas occupies 22.4 liters. Now here we have 2 moles, which means we are going to say that 1 mole is equal to 22.4 liters. What about 2.0 mole is equal to, or what about 2.0 mole is equal to X? So how are we going to find the value of X? So we are just going to multiply 2 mole times 22, which means the answer is going to be 44.80 liters, which means the volume that the 2 moles of gas occupy at standard temperature and pressure is 44.8 liters. We just used the condition, which is 1 mole of any gas is equal to 22.4 liters. So let's go ahead and do the last example, which is the example 3. Another example, a gas occupies 11.2 liters at standard temperature and pressure, how many moles are present? So we just do what we did earlier, which is 1 mole is equal to what? 22.4 liters. What about here? We have been given the liters, which means we are supposed to put on the right side 11.2 liters. Then we put x here. So our aim is to find this x. We are going to find that x is going to be 11.2 liters more over what? Over 22.4 liters, which is liters and liters will go. We are going to have more, which is 0.5 more. So that's our final answer. That's our final answer. So that is how we find the number of moles given the liters, the volume, or how we find the volume given the number of moles by just using what we say 1 mole of any gas occupies what? 22.4 liters of an ideal gas. So thank you for watching, guys, and don't forget to subscribe for more lesson videos, because in the next video we are going to be talking about gas stoichiometry. Yeah, so there are other lesson videos coming up, so don't forget to hit the subscribe button. Thank you for watching.